So step 2, defining CBTC user priorities and concerns. So if we go back to our diagram and look at the environment, we have our CBTC system in the center. We have the operating environment that's enveloping it. Now we need to define who are the users of this CBTC system. So we start listing them out and adding to this mind map. So if we start off, we can say that there are operators. There's the yard operator, as well as the mainline operator. They're the ones controlling the system, seeing all the trains on the system, when it's being launched, when it's being taken out of service, if there's a problem, if there's a need to react, etc. We can add train drivers. They're the ones in the tunnels driving those trains. We have maintenance personnel, and that can be broken out further into trackside and vehicle maintenance personnel, who are the individuals that actually maintain the system. We have instructors, who are the ones responsible for training all the personnel in how to operate the system. We have IT personnel. They're the ones that maintain the network, the wired and the wireless. Emergency first responders. Now, at first blush, you would not think that they are a user of the system, but they are. They do have requirements. When there's an emergency at track level, they need to make sure that the area is clear of all trains, that traction power is cut, tunnel vent doors are closed, and the ventilation fans are on, etc. So they have an input into the system. The CBTC system may be controlling some of these things. So they are definitely individual or users of the system. And finally, passengers, for obvious reasons. They are the individuals, they are the people, your ridership, who are using the system day in and day out, and they definitely have an input in terms of what type of a CBTC system that they need. Now, once we have defined all of the users of the system, we need to understand what are their priorities and concerns. So we just continue along the same path that we've been following and keep adding to the mind map. So if we start off with the train drivers, we can say that the train driver is concerned with the status and the alarms, train modes, the availability, vehicle redundancy, trackside redundancy. And these are their concerns. Because the driver, they need to know what the status of the train is. If there are any alarms coming in, do they need to react? They need to know what type of modes are available to them. Is there fully automatic? Is it an ATP protected? Is it manual or cutout? And see, these are the concerns for the train driver. For maintenance personnel, they're concerned with reliability and maintainability. If we look at the trackside personnel, they're concerned with level 2 diagnostics. Level 2 diagnostics is my term. I defined it in a white paper I wrote on the 7 key CBTC function transit operators should understand. You can download that white paper from my website, and it can go into more detail on what that actually means. But the point here is they need diagnostics. They need to understand if there is a problem, where it happened, and to isolate it and localize it so they can get to it as soon as possible. Trackside special tools. Is there a laptop? Is there a special cable? Is there special equipment they need to maintain their system? That needs to be defined. Work zone protection. When trackside personnel are at track level, how are they protected? Because if the system is in operation during revenue service, there needs to be a mechanism in place to be able to protect those workers all at track level. Because in a CBTC system, trying to protect workers at track level is very different from a traditional system. Work cars. Work cars need to be, these are cars that are used to take maintenance personnel at trackside and get them to the destination where the problem is. The problem here is, should the work cars be tracked? Should they be managed by procedure? These are the questions that need to be answered for work cars. For vehicle personnel, it's no different. They need to have special tools as well as diagnostics, no different than the wayside, to be able to do their jobs. For the operators, some of the concerns that may pop up is for the yard operator, launching trains into and out of service, moving trains around in the yard. For the mainline operators, they need to have reports to understand how the system is performing. They need to have the ability to recover failed trains. Now, how do you recover a failed train? Do you have secondary train detection or follow that mode of operation? Do you use procedures, or is there something designed into the CBTC design which can recover these trains? The operators are concerned with regulation, recovering from a perturbation in the system, availability, and if we break that out further, we could say redundancy of central, the trackside, the vehicle, the network. They need level 1 diagnostics. These are alarms that are coming in indicating if the train emergency braked, if it was able to reset its emergency brakes, if the doors did not open, if a switch is stuck. Alarms that indicate if there is a problem that needs to be addressed. The user interface, this is the GUI that the operators are using. Is it user-friendly? Are there certain colors you want? Or is there a certain layout that the personnel, the operators need? And then finally, a cutover strategy. If it's a simple, small system, you may go with a big bang approach and just cut the whole system over to CBTC in one shot. Or if it's a long 30-kilometer line, you may break it up into phases. But it's a discussion that needs to take place of what type of a cutover strategy that you need that will have the least disruption to your ridership while trying to deliver the system as fast as possible or as soon as possible. Moving on to the instructors, their concerns are having tools to be able to train the personnel. They would need a trackside simulator, a central simulator, a vehicle simulator, and the training material that goes along with it for them to be able to train the personnel properly. IT personnel, they are concerned with the network itself, the wired and the wireless. They are interested in network security. When you have a wireless network, anyone can access it. So what kind of security is in place? Is it encryption? Is it authentication? So they're concerned with security. They need level 2 diagnostics to be able to find out if there's any problems in their network. The network needs to be reliable and there needs to be redundancy. So these are some of the concerns from an IT perspective. For the passengers, they need to be informed of what's going on, whether it's on the train or on the platform. Such information such as the next platform they're traveling to, how long will it take before the next train arrives, if there's a problem on the track, why they stopped. Information just to keep them informed of what's happening. So a PIS-PAS system is a concern. Platform doors, train doors. This is the doors that are used by the driver or by the ridership. So it's a very critical piece of infrastructure. Are the doors wide enough? Can it handle handicapped? Can it handle wheelchairs? If a train gets stuck, how many times it's going to recycle? Questions of that nature. On-time service. Obviously, they want to make sure that the trains are arriving on time and moving and taking them to their destination on time. Ride quality. You don't want passengers to be jerked around on the train. So you don't want a hard braking, hard acceleration. It needs to be a nice, smooth ride. And when it comes into a station, it should be a nice, smooth stop. So it's a concern for a passenger in terms of ride quality. In a traditional system where you have a driver on board, every driver has its own driving characteristics. In a CBTC application, all trains are the same because it is an onboard unit which has been programmed, which is identical on every single vehicle. So ride quality is a concern, and there are requirements that can be placed on the CBTC system. For emergency first responders, as I mentioned earlier, if there's a problem on track level, they want to make sure that the trains are cleared from the trouble zone, traction power is cut, tunnel vent doors are closed, tunnel ventilation doors are on, and there may be other requirements from the first responders for them to be able to react to any emergency situation. So once we've gone through this exercise, we've identified all the users of our system, we've identified all of their concerns and priorities. Now we need to understand what are the system capabilities and try to feed these concerns and priorities into the CBTC system. And that's what brings us to step number 3, which is to translate these priorities into system capabilities.